Hello, we meet again on Mr. Bejo's tutorial channel. This time I want to share a QGIS plugin that functions for ship navigation. As a disclaimer, I use GPGGA simulation data, heading, in depth with Python as the data stream. I do not use real hardware. This software functions to read GPS data, heading, and depth that can be used for bathymetric surveys or as gunboat navigation. I use VSPE software for the virtual COM port. So it seems as if the survey sensor data comes out through the COM port and is then read by my plugin. In VSPE, I created a virtual pair connection. This way, it would appear as if GPGGA GPS data would be output from COM port 51, heading port 71, and depth port 61. I also created a pair of ports 80 and 81 that function as trigger outputs. The GPGGA data format is an NMEA data format that reports GPS position, while the HDT format is a Euro compass data format or ship heading. Then there is the DPT data format as a depth data simulation. Let's return to the QGIS interface and reopen the RX-Bejo logger plugin. After I created a virtual COM port, it wasn't detected by my plugin. So, you'll need another QGIS plugin called the Reloader plugin. You can find this plugin in the plugin manager. To install the RX-Bejo logger plugin, you can download it from my GitHub by typing Aryo Danang Satrio and then selecting the RX-Bejo logger repository. Here, I've also provided a sample script and sample data that I use. After downloading the RX-Bejo logger zip file, you can install it through the plugin menu. Select Manage and Install Plugins. Then, select Install from Zip. Install the zip file you downloaded earlier. You can also find Plugin Reloader here. On the first tab, you can test whether the data stream from the sensor has been read. Select the appropriate COM port. In this case, I'm using port 51 for GPS data, port 61 for depth data, and port 71 for heading data. Select the appropriate boot rate for your device to ensure proper reading. The next tab is the Create Vessel tab. This menu is used to draw your vessel. If you're using a car or truck for navigation, you can also create one. On the right side, there's a menu for adding local coordinates to your vessel. Point 0, 0 is the VRP point, or vessel reference point. This point will serve as the center of the calculation. You can place the VRP point in the center or rear of the vessel, depending on your needs. In this example, I created the VRP point in the center of the vessel. Then, input the local coordinates in meters for the sides of the vessel to create a similar shape to the original. Next, enter the offset of your sensor to the VRP position. Enter the actual position of your device with a distance of meters from the VRP in local coordinates. For example, I have a GPS located to the right of the VRP as far as 3 meters. So I type an offset of 3.0. Then also enter the offset of your echo sounder and heading tool. In the bottom left menu, There are two options, equipment and nodes. You choose equipment to determine the position of the GPS, echo sounder and heading sensor. Then, if you want to record coordinates that do not have a sensor, for example, the center of source, then select nodes. If there are other coordinates as layback that you want to record besides the center of source, then select Other and type the name and coordinates. This software is actually specifically for marine seismic work, namely for gunboats. That's why there is a center of source or vibration source position. If you have finished building a vessel, don't forget to save your vessel file. You will always use your vessel file when surveying. This file is saved in .json format. You can also load the saved file and edit it again if necessary. Then don't forget to save your edits again. Now, go to the main menu of this plugin, which is Start Survey. This tab menu is used to start your vessel navigation. Select your vessel previously created in the .json file. In the GPS port options, select your GPS port. For me, I chose port 51 for GPS data. Set the boot rate to match your device. Then, select your heading sensor. Then, enter the heading correction value, if any. If you don't have a heading sensor, don't worry. I've included a GPS heading checklist so the ship's direction will be read according to GPS movement. Then, select your depth sensor or echo sounder. You can enter a positive draft transducer value. This value indicates how deep your transducer is from the water surface. The resulting depth data is the depth data from the transducer plus this draft value. If you wish, you can save your vessel's position tracking to a file. This tracking is based on the VRP position. Remember, the longer your survey, the larger the file will be. Once everything is ready, you can click the Start Navigation button. Use the Start Tracking button if you want to track your vessel's location. It seems my heading simulation is a bit messed up, making the ship appear to be turning. Now let's see the difference when using headings from the GPS track. To add a display in QGIS like mine, you can go to the View menu and select New Map View, then set the view rotation to face the front of the ship. I will reset my GPS data simulation so that the ship's position is on the first track. Now let's try tracking the vessel. When we click the Start Tracking button, a new layer will appear in QGIS. During the survey, do not delete this layer. Doing so will result in an error. If the QGIS display is already too crowded, you don't need to delete it. Simply uncheck the layer to keep the display clean. The Always Center button keeps your vessel centered, eliminating the need to search for its position. In the Nodes menu, you can also record your sensor positions or other layback nodes, such as the center of source or the ship's rear position. These nodes depend on when you created the ship in the previous method. Select the sensors you want to display in QGIS. Then press the Start button. This will add as many layers as you choose. Remember, don't delete these layers during the survey. These layers are not stored directly on your storage. I created the memory data type by considering the speed of data updates. You can export this memory file as a shapefile and save it to your storage by right-clicking the layer, selecting Export, and then selecting Save Features As. Do this periodically to avoid losing your data. Or, if you want to save all the nodes formed on your ship, you can select Backup Tracking Nodes in the CSV file. Then select a save location, and then click the Start Log button on the Nodes tab. Remember, the longer your survey and the more nodes you record, the larger the file will be. Make sure you have enough storage space. If you're only conducting a bathymetric survey, the previous menus are sufficient. However, if you're working on a gunboat and want to conduct a seismic survey, you can go to the GEO or Guidance Object menu. I've included an example of a guidance object file format in CSV format on my GitHub. Load theoretical data for the coordinates of the target. You can create your own guidance object file, provided the first column contains the track name, the second column contains the point number, the third column contains the easting coordinates, and the fourth column contains the northing coordinates. The title of each column will be like this: line, no, east, north. This must be readable. Select your steering point. The steering point is the point where the calculation of the target will be made. For gunboat shooting, the steering point is usually based on the center of the source position. Then select the target track. Then enter the target point number. Choose whether the number continues to increase or decrease or decrement. This depends on the direction of your ship. In the Step menu, enter 1 if the target point number is added every 1 interval. Click the Compute button to calculate how far you are from the left or right of the target. You can create a corridor on the Mark and Corridor tab. In this example, I created a 20-meter corridor, meaning 10 meters to the left and 10 meters to the right. Once you've reached your target, press the Mark and Shoot button. This will add another layer. This layer represents the steering point's position relative to the target. Remember, don't delete layers during the survey. You can record your Mark and Shoot results in a CSV file. To shoot during a seismic survey, you must connect to the gun controller. Check the Send Trigger menu to trigger the gun controller via the fixed box. Select the appropriate COM port and boot rate. If the Special Character menu is unchecked, the trigger output will be position data. However, if your fixed box has a unique way of reading characters, select the Special Character menu and type the character you want to send to the fixed box to trigger the gun controller. You can mark objects outside the Marking and Corridor tab. For example, if there's a dangerous position during a survey, you can mark it on the map or save it to a file. You can record the object's position based on the VRP position or enter coordinates manually. In the Depth Profile tab, you can view the depth graph from the Echo Sounder sensor. I've included instructions for using this plugin in the last tab.